Hi, okay. My name is Mary Pendleton, and my research project is on the effect of rainfall on biodiversity. One of my favorite spots to go camping is in Duchesne on my parents' private property. It's called Paradise Pines, and we go up there throughout the summer, and it's a lot of fun. Well, last year my parents dug their first well just to have some water up there for showers and things like that. And when I was getting water out of the tank, I noticed a worm in it, and it kind of freaked me out. And I started wondering, I wonder what else is in the water. Is there, organisms living in the water? Because it just comes straight out of the ground. But this environment is a desert. There's cactuses. They don't get a lot of rainfall, and so my thoughts were that a desert environment maybe has less organisms living there. So my question is there more biodiversity in locations with higher rainfall? This is important because it basically tells us how the environment affects organisms, and we were able to study different environments and see the effect that it has on them. We're basically studying ecology and how the organisms interact with the ecosystem. My hypothesis is that locations with higher rainfall, such as more than 10 inches per year, will have more biodiversity than areas that have less rainfall, which is less than 10 inches per year. My reasoning behind this is because we all know that water is essential to living things, and it has so many unique and useful properties that are basically necessary to life on Earth. And since we've been learning a lot about natural selection, we know, like Darwin's theory, basically he talks about how organisms that create more offspring organisms create more offspring that can be supported by the environment. Well, if there's a limiting reagent, then there will be natural selection that basically determines which of those organisms will survive. And since there is less water in places that get less rainfall, that is the limiting reagent that basically determines if there will be natural selection. And so in desert environments, I figured that would have less biodiversity because of the natural selection allowing less organisms to survive. But in places where there is abundant water source, there will be more biodiversity because more organisms, it can support more organisms essentially. So I chose two lakes. Starvation Reservoir is actually up on my parents' property, and it gets 7 to 10 inches of rainfall per year. And then Deer Creek Reservoir gets 24 inches of rainfall per year. So those are the two lakes that I decided to use to get my samples from. I took 2 samples from each lake, and I chose the same location for each of the samples. So I went back to the same location about a month later to get the second sample from each lake. Then I brought them back to the lab, used a microscope by taking a drop of water, putting it on a slide, and observing the organisms that were in that water. And then I recorded the number of organisms and the type of organisms that I observed. This shows a map of my sample sites. So here is Deer Creek. This little bubble right there shows where I took that sample from for Deer Creek. And then over here is Starvation. So that's where I took the sample for the Starvation Reservoir. And you can see even here that this is more of a montane, foresty environment. There's a lot more green on this map, whereas over here there's no green, or it's very little green. So it's much more of a desert environment. My results are summarized in this table here, so it shows that I observed 5 different species in Deer Creek, and I observed 4 different species in Starvation. Both locations had nematodes, diatoms, and chlamydomonas, and there were also 3 organisms overall that I was not able to identify, 2 of which were in Deer Creek, 1 was in Starvation. So in Starvation, the most abundant organism that I observed was the chlamydomonas, And I think this was because on that sample, I left the lid on after I got the sample for a couple of days. And so because of a lack of oxygen, I think a lot of the organisms may have died, which allowed for the Chlamydomonas to continue to reproduce, which increased the amount of Chlamydomonas in that sample. So that might not be accurate with what's actually in the lake. But I observed a total of 29 organisms in starvation, the samples from starvation. And starvation had the most overall organisms observed because of the Chlamydomonas. Oh, I'm sorry. And this is a nematode that I observed in the starvation samples. You can see its tail coming down this way. In Deer Creek, the most abundant organism that I observed was the diatoms. There were a total of 17 organisms that I observed. This picture right here shows 5 diatoms in one picture. You might be able to see them. So there's one here. Let's see, there's another right here, just a little one. There's a little guy right there. There's one down here. And so those are all the diatoms that I found. Some of the diatoms that I found in Deer Creek's sample. So Deer Creek actually had the most biodiversity because there were 5 different species compared to starvation's 4 different species. This graph shows my results for the total number of organisms that I observed per sample. And so the blue and the red are starvation, and then the yellow and the green are Deer Creek. So you can see starvation had the most overall organisms that were observed. And then these charts show the breakdown of those organisms, so what was found in those. So in starvation, you can see that the vast majority of it is Chlamydomonas, with some diatom, a nematode, and another unidentified organism. Whereas Deer Creek, the vast majority of it was diatoms, with some Chlamydomonas, some nematodes, and some unidentified. So there were four different species in starvation, 5 different species in Deer Creek. Okay, so this chart I like because it shows basically an overall comprehensive view of everything. So each of these is the samples. So these 2 are from starvation, these 2 are from Deer Creek. In starvation, you can see that most of those organisms come from the Chlamydomonas, which is right here in yellow. The blue shows the total overall organisms in that sample. And so you see if we take out the Chlamydomonas, there are actually more organisms in the Deer Creek samples than in the starvation samples without the Chlamydomonas. So if that had not happened, what I believe happened, that the Chlamydomonas reproduced uncontrollably, there may have been more overall organisms in the Deer Creek sample. Okay, so the question is, was there more biodiversity in areas with higher rainfall? Well, Deer Creek did have more biodiversity, but it was just barely. They had 5, whereas starvation had 4. And starvation also had more living organisms overall. I believe that a bigger sample size would be able to tell us if there is actually a significant difference and verify our data. And so by observing more samples or just spending more time observing organisms would allow for that. There were a lot of diatoms in Deer Creek, which tells me that that lake is healthier because diatoms usually are an indicator of water quality. Some limitations and error that may have occurred. My first 2 samples, like I mentioned, I left the lids on, and so that might have caused some error in some of the organisms that died and allowing for the Chlamydomonas to reproduce. If I had had more time, I may have been able to collect more data. So if I had spent some more time observing those organisms, I may have been able to offset that a little, and possibly getting another sample, redoing that sample basically where I left the lid on. Also, the 3 unidentified organisms, it would be good to be able to identify those to add that to our data. And then there are also other things that might contribute to the difference in organisms, such as human interactions, introduction of chemicals in the water, and the amount of sunlight that's in the area. So just depending on where I took the sample from, how much sunlight was it getting, was it in the shade, So my conclusion is that my hypothesis was technically supported in that the area that had the higher rainfall did have more biodiversity. However, they were extremely close, and so because of that, I think that I would say that the results are inconclusive, and further research would need to be done to determine if the difference in biodiversity is significant. For future directions, I would recommend testing samples from other locations with possibly more extreme climates, like having less than 4 inches of rainfall or more than 50 inches of rainfall. And also just taking more samples and spending more time observing the organisms to add to your data to have it be more comprehensive. I'd also be interested in testing a sample from my parents' well just to see what lives in the water there, because that water comes directly from the ground, so just to see what's living in there. I'd like to thank my husband Brett for driving with me 4 hours each time that I needed to get a sample. And thank you to Dr. Santa Martinez for helping me to identify a lot of the organisms. And also somebody in the class helped me with the microscope, and I don't know their name, but thank you to them. These are my references that I used to find the annual rainfall for each location. And that is it. So thank you for